Alright, in the first video we talked about how we find the derivatives of an inverse function by either using the formula or implicit differentiation. Now we're going to talk about how we can differentiate inverse trig functions. Here, one quick observation is that when we start with f of x equals ln x is a logarithmic function, but turns out that its derivative is an algebraic function. And that's an interesting observation because the same thing happens for inverse trig functions because their derivatives are algebraic. And here's the formula card for you, which is also in your derivatives formula card. So we have the derivatives of all 6 inverse trig functions, and they all come with the argument u. You can take that u as a function of x, as stated here. And as you see that in each case, you have the derivative coming out as an algebraic expression here. And one another observation here is that just for your reference, so look at the first column here. You have 3 different types of derivatives here. And on the right hand side in the second column, you have all of those multiplied by -1. So like for example, the derivative of arc sine of u is u prime divided by radical 1 minus u squared. And cosine, the derivative of arc cosine is the negative of the derivative of arc sine. And same thing here is valid and as well here. So in other words, if you know the derivatives of all 3 functions here, arc sine, arc tan, and arc secant, and the derivatives of arc cosine, arc cotan, arc cosecant are the minus versions of those. So here is a few observations again. Well, first off, there is no common agreement on the definition of arc secant or arc cosecant for negative values of x. And you will see that arc secant x is going to be found by arc cosine 1 over x. And also in your calculator, you probably don't have arc secant, so you can use arc cosine of the reciprocal of x to evaluate arc secant of x. Like as an example, arc secant of -2 is arc cosine of -1 over 2, which is negative half, right? So then this is something that you can use your calculator for and get a value at the end. And another one is that the inverse secant function, if you look at its graph, that has a positive slope at every x value on its domain. So it's essentially because of the absolute value sign in its formula, which is right here. Okay, so you have the absolute value sign here. So for that reason, you have the slopes coming out positive. All right, we have 4 examples four quick examples, in fact, to go through before we close this video. So we have the derivative of arc sine 2x. So you can take this as u. Okay, u equals 2x, and the derivative of arc sine is u prime divided by 1 minus u squared, right? This is the derivative of arc sine of u. So u prime in this case is just the derivative of 2x, that's 2. And 1 minus u squared is 1 minus 2x quantity squared. And if you simplify that, you have 2 over radical 1 minus 4x squared. Let's check out the next example. That's arc tangent 3x. And arc tangent u, calling this guy to be u, has the derivative u prime over 1 plus u squared. And all you need to do is just to check for u prime for u equals 3x. And that's 3. And we have u substituted here. So eventually we have 3 over 1 plus 9x squared. And here's another arcsine function, but this time the argument of that is different. So let's call u to be radical x. Remember that arcsine of u has the derivative u prime over 1 minus u squared. What is u prime? Well, u is radical x again, and that is x to the power of 1 half. And if you use the power rule here, so for u prime, we have 1 half x to the power of -1 half. Okay, and that's exactly what we have here. And we also have 1 minus u squared, and that is 1 minus radical x quantity squared. That's in fact x. And the next is to simplify this. And remember that this term here is written as the reciprocal. So that is x to the power of 1/2. But in other words, this is 1 over 2 radical x. So this term is replaced by 1 over 2 radical x, and this is exactly what you get at the end. Here is the final example that we're going to go through. We have arcsecant e to the x. Call this function to be u. And the derivative of arcsecant u is u prime, absolute value of u squared minus 1. Okay, what is u prime? Well, u equals e to the 2x, so u prime is just using the rule for differentiating exponential functions whose exponent is a function as well. So you take the derivative of the exponent and multiply by itself. So this is the derivative of u. And we have absolute value of u. What is absolute value of u? Well, this is absolute value of e to the 2x, but just because of the property of exponential functions, they're always positive. So you can easily get rid of the absolute value because, again, they take positive values. And you're going to plug everything back here. And this is u squared. So e to the 2x quantity squared is going to be e to the 4x. And you can also divide out these guys because these are like terms. So in turn, you have 2 over e to the 4x minus 1 as the result of this integral. All right, we're completely done with 2 learning objectives of this section. Next, go ahead and start watching my recitation videos where I go through practice problems with step-by-step approach and practice the content over there because you have more non-trivial examples gone through by me, and then you are ready to start the homework assignment. All right, thanks for watching. I'll see you in another video.